We often measure the legions of Rome by the clash of swords and the disciplined ranks of heavy infantry. Yet the empire's expansion relied on a less cinematic, far more methodical process. For most of ancient history, a walled city presented a massive problem. Armies usually relied on starvation, sitting outside the gates in long, uncertain blockades that often ended with the attackers dying of disease or running out of supplies themselves. By the late Republic, Rome moved away from this uncertainty. They began approaching the siege as a brutal, predictable engineering puzzle, with walls treated as physical obstacles to be overcome on a fixed timeline. The foundational instrument of this shift was carried by every single legionary, an iron delabra. Within hours of arriving at a target, the soldiers put away their weapons and began the work of transforming the landscape. This approach redefined the wall as a purely mathematical problem. Once a fortification was measured and its weaknesses identified, the fall of the city became a simple matter of logistics. Upon arriving at a hostile city, the legion's opening move was not an assault, but the construction of a fully fortified camp. Specialized surveyors used an instrument called a groma to map out strict perpendicular axes. They imposed a rigid military grid onto the raw terrain, ensuring the legion operated from a position of total security. Engineers dug two massive rings of earthworks. An inner circumvallation line trapped the city, while an outer contravallation line repelled relieving armies. These lines utilized standardized components: deep trenches, tall palisades, and concealed pits filled with sharpened stakes. At the siege of Alesia in 52 BC, Julius Caesar's troops constructed nearly 40 kilometers of these fortifications, effectively enclosing a Gallic army inside a Roman-made cage. The legion succeeded by building a superior, inescapable fortress around the enemy's own city, leaving the defenders with no room to move or breathe. Once the target was contained, the Romans began an offensive suppression layer using a level of mechanical artillery that would not be matched for a millennium. They utilized flat trajectory ballistae and smaller scorpiones to target individual defenders on the walls. These machines were accurate enough at 300 meters to pick off specific officers. For heavy demolition, they deployed the onager. This stone thrower hurled rocks weighing 20 kilograms in high arcs, smashing the upper battlements and crushing anyone stationed there. By massing these engines, the Romans could clear a stretch of wall from a safe distance, making it possible for assault troops and heavy equipment to approach the base of the fortifications. When facing cities built on steep hills or rocky plateaus, Roman engineers bypassed the terrain by simply constructing their own roads to the sky. At Masada, the 10th Legion moved enough earth and stone to build a massive ramp scaling a 400-meter plateau, a lasting monument to the scale of disciplined Roman labor. Up these inclines, they pushed multi-story siege towers and battering rams. These massive structures were sheathed in soaked hides and wet clay to prevent the defenders from burning them. Once the ramp reached the wall, the battering ram began its work. The rhythmic strikes of the iron-shod timber focused tons of force onto weakened masonry until the defense finally gave way. While the towers and rams focused on the surface, sappers worked beneath the battlefield. They dug tunnels under the foundations, propped them with timber, and then set those supports on fire to trigger a collapse of the wall above. Defenders dug intercepting tunnels, leading to frantic, blind combat in the dark, fought with knives in the choking dust of the deep earth. Roman engineers systematically dismantled defenses from every direction, exerting pressure from the air, at eye level, and from the deep earth simultaneously. Roman siegecraft achieved its lethality through the simultaneous orchestration of every tool in the arsenal. To a defender on the wall, the sight of multiple towers moving forward through the smoke meant the end was already certain. They faced an impossible dilemma, trying to suppress the rams and scaling ladders while their battlements were crushed by stones and their foundations were burned from below. This technological system was so effective that it remained virtually unchanged for over 1,000 years, persisting until the invention of gunpowder in the 15th century. This long-term success was built on institutional doctrine. Roman commanders operated with standing manuals that dictated the precise volume of labor and tools required to overcome any given obstacle. While other ancient armies relied on the chaos of a storm, Rome relied on the muscle memory of its soldiers. They didn't just fight for a city, they scheduled its destruction.